All right, good morning. Well, for the people that don't know me, I'm Jake Anderley, lead agronomist for Legend Seeds. I also work on the Yield Master Solutions side as a technical agronomy lead. So today we're going to talk about a product that's been in our lineup. It's called RhizoStack Rhipel, so formerly known as Terrasim 450 plus Dust plus TS201. As we go through this, you guys will see some of the slides still have the old TO or the TS201 or it'll talk about. Just know that that is now the Rhipel piece, and I'll kind of explain that as we go. So we'll jump into it here. So we're going to start off and talk about PPFMs. So PPFMs up there at the top, I'll save myself from butchering what they are. So this product, the RhizoStack Rhipel, the two components of this product are considered PPFMs. So they're a pink bacteria. PPFMs are found in all plants all over the world. If you go outside, not today, obviously. There's not a lot growing out there. But if you were to take leaf tissue out of plants that are in the woods and a tree line, something like that, and you looked at it, there'd be different, and under a microscope, you would find different strains of PPFMs within those plants. So not all of them have a function of what we want them to do within the plant, say an ag. But there's about, I believe, there's 14,000 different strains of them that have been identified out there, and we still, as an industry, still don't know what each one of them does. But so what PPFMs do, so they have a unique methanol metabolism process within the plant. And that's probably the most important piece of this with the last point that's on this slide. So what metabolizing that methanol is doing in the plant is once that the methanol is broke down, it triggers a response in the plant that kind of helps it fight off abiotic and biotic stresses both. So it's also used once it's broke down. The metabolites that are used from that process get used for different things. It's an energy source for cells, helps build and strengthen cell walls, some of that kind of stuff. But that's what makes them unique in their class of bacteria, is that methanol metabolism. So they colonize in the plant very efficiently and effectively, and all over within that plant. So they're not just colonizing only in the roots or only in a certain leaf or anything like that. They're within the entire plant, and they're very robust when they colonize. So that's the one thing that does make them unique, unlike some other products that are only on the industry that are only working in certain areas. These are working through the entire plant. So, and then if you look there on the far right, the increased nutrient uptake for enhanced rooting and strength. So we'll talk a little bit about that here. And just all the Terrasim strains, whether we're talking the Terrasim 450, which is now the private label through Yield Master called RhizoStack, for both corn and soybeans. Even on the soybean side, you will see that enhanced rooting. It's just a characteristic of the bacteria. They stimulate the meristematic tissue in the roots to kind of give you a little bit bigger root system. On the Rhipel side here, we'll talk why that's important in just 1 second. So here's just some data. So this is from the supplier. So Terrasim 450. So this is the RhizoStack component to the product that we're going to dive into. So performance, 4.9 bushel average when you take all of the data points into consideration, even some of the negatives that are out there. When it's got a positive response, it's 8.5 bushel the acre with a 70% win rate. And that data set is from 2020 to 2024. So this is third-party data. We'll be releasing our internal data on the NutriQuire Terrasim, which has 450 in it, the RhizoStack. Though we'll be releasing that here in the trial data booklet here in a couple weeks. So, but looking at that 227 trials, so this isn't a small sample size or anything like that. This is quite a large data set, third-party data. So with that, what the Terrasim 450 is doing, and there's greater nutrient uptake. We talked about the enhanced rooting, more consistent performance, and what I've seen is more, especially in corn, more consistent earing down the row, more and better tip fill, which ultimately all of that leads to higher yields. So looking at the rooting here, so this was a trial done in Rosedale, Indiana. So if you look at, so the untreated check is on the left, the Terrasim 450 roots are on the right, and this is very early. I believe it's V4 or V5 corn. So real young in the corn's life. We're not looking at a mature root system here. So an overall increase, 6.2% of total root area, 5.2% rooting depth. As you see, the roots are getting a little bit deeper, a little bit longer, and 9% in the length there. So the other thing that's important, and I'll talk a little bit about this, and something in the Terracin products and overall plant health. There's a product coming out called TS601, which we'll talk about at a future date. But the leaf tissue iron concentrations and leaf tissue manganese. So the unique thing with Terracin is it also helps uptake micronutrients, particularly iron and manganese. Both of those, when we're dealing with diseases, say in corn, let's say tar spot or northern corn leaf blight, those diseases, if we have the right environment, everything are going to hit the plant no matter what. If we're deficient in micronutrients, specifically some of these micro metals, it's going to compound that problem. And so just on the Terracin 450 component alone, my observations in the field across a lot of different trials, we do gain a tiny bit of health component to just the Terracin 450 as a standalone, which is called RhizoStack. That bacteria seems to bring just an overall vigor aspect to that plant. And then in the future, the TS601 will be kind of the product that ramps that up. So, okay, so here's the product we're talking about. So RhizoStack Rhipel. So this is going to be a co-pack product. So if you see there, you got the one pack of the RhizoStack, and then you've got the Rhipel. So the RhizoStack's the 450. The Rhipel is formerly known as TS201. So it's still going to come in a cold pack for 2026 here. So it's a planter box treatment that suppresses corn rootworm larvae. And we talked about the increase in the root growth, and then that ultimately leads to yield. The dust component that's in the RhizoStack replaces talc and graphite for seed lubricant and meter conditioning. That's also in there, so there's no need to add talc or graphite to this product. It's actually something we do not suggest doing. It's a half-ounce use rate in the box, so it's very minimal. And it doesn't look like a lot of guys look at it and they're like, oh, I'm not going to get enough product in there to do what I want. Graphite, I call it the moron theory. We just put more on, and we think we're doing a good job. That's not the case with this. It would get very expensive, number one. But you don't need to have full coverage on all the seed. All of the treatment is done when the seed is going through the meter. It works through static electricity. The PPFMs are a negative charge, so they spread all over the seed. It's kind of a unique process, but we don't have to visually see it on every seed to know that it's working. So what the Rhipel does, and this is the kind of the part I'm going to focus on today, the Rhipel produces a product called jasmonic acid in the roots. So it will also express it in above ground tissue as well. But what jasmonic acid does in the insect world is it blocks essentially the guidance mechanism in larvae. So corn rootworm larvae, when they hatch, they're essentially moving through the soil profile, and they're guided by CO2 signals. They don't have eyeballs, but they have a sensor that can sense CO2 concentration. So as the roots are exuding CO2 into the soil, they follow that concentration gradient as they're kind of wiggling through doing their thing. So what that jasmonic acid, when they hit that band of jasmonic acid, they will either stop, and because it's kind of like, messing with a computer, giving a computer a virus, they don't know what to do. So they kind of just stop, and or they will turn and go the other way. And I've got some interesting studies that have been done on that to kind of show that live time. But so essentially what happens is, instead of moving to the root and feeding, those larvae will not actively go out and search for a root unless they know where they're going. They're not like me. They don't have fat reserves to essentially live for days on end. Corn rootworm larvae got to feed within 24 hours or they starve to death. So it's very effective. It's not a biocontrol. We are not actually killing the larva when they hit this band. So I shouldn't say biocontrol. I should say bioinsecticide. It doesn't necessarily kill it. It's a biodeterrent where the larvae are not getting to that root system and they die of natural causes. So, the other component to this, and I've got some really cool images and pictures from some of our plots and some of the research data. So RhizoStack will regenerate roots. So that's why this is a two-part product. I get that question all the time. Well, Jake, the rootworm is what we want. Can we just dump the Rhipel in the box and call it a day? The RhizoStack component, so the Terrasim 450 is what it was known as before. That product will regenerate roots that have been damaged. It'll go up to the next node on the root system and essentially kind of paintbrush those roots out and give us more root system where we normally wouldn't have anything. It also helps kind of helps heal that infection point or that feeding point. And then it's also helping move those nutrients around more effectively in the plant. So that's why it's kind of a two-part product and why we don't have the 201 as a standalone. So. Okay, so here's some multi-year data. So this is from the supplier again on the RhizoStack Rhipel. So this is the co-pack. So as you can see there, this is one thing on the YieldMaster Solution sides, even before I started on the agronomy side with them, we have never hidden data and we've never hidden the negatives. We realize that no biology or any biological that's in the marketplace today, including our own, is ever a 100% win rate. I've been in ag. Now this would be my 11th year in my career. Grew up around farming, and I can tell you, and I know a lot of farmers, I can tell you that there's no 100% guarantee in ag today. It's just not out there, and so just like that, we recognize that, but we're not gonna hide that data. So looking at this, including the negatives, so 5.6%, or excuse me, 5.6 bushel performance, including the negatives. So just overall. With a win, so essentially from, I don't know if you guys can see my cursor here or not, if you go straight down from the 9 and go straight down, essentially that's where you start winning. When you only include those positives, it's a 9 bushel average response with a 72% win rate overall. So this is 2-year data, 81 trials. And so some of you guys are like, man, that's a big data set. And some guys are really like seeing data like, oh, it's only 2 years of data. So I actually included another slide, and this is probably one of my favorite ones. So this is data from the supplier going back to 2016. So some guys, question like, okay, this product's out, how many years of data, how many years have you seen it? So they were looking at this product 2016. So we're almost essentially 10 years ago. So this product is kind of newer to the marketplace. We've been carrying it through YieldMaster. I believe we're going on year 3. It just got private labeled this year's RhizoStack Rhipel. But looking at that product across the years in performance. So this is studies that were done on traded and untraded corn, multiple replications across multiple states. You guys can see the detail of the study over there on the right. So we had 2016 20.7, then 2017 13.2, 9.9, 12.6, 15. And then, like I said, there's always that one instance where you call it a coin flip or a no response at 0.3, and then a 4.9. If you guys remember back to 2021, that was we were coming off of a really, really wet year in 2019, and even some areas were wet in 2020. So a lot of larvae, essentially, when we get into that 2021 timeframe, there was a lot of larvae that essentially died of natural causes from saturated soils. So the counts weren't as high, so that's kind of explainable why there wasn't a huge response there. But just overall consistency in the data, you have your highs, you have your 20s, but if you average all those numbers out, it comes about 9 is what you end up with. So seeing that consistency year over year over year in data is what we really like to see. Okay, so I'm going to dive in here now to kind of how it works. So in a plant, there's all sorts of different types of defense responses. So you see at the top there, you have systematic acquired resistance. Then you have herbivore-induced resistance. If you're like me and live in Wisconsin or up north, we have lots of that in the form of 4-legged brown creatures called deer. We'll explain that in a minute. And then induced systematic resistance, and that's the one we're going to focus on. So up at the top, the systematic is essentially the natural defense mechanism that hits. So when a plant gets a disease, so I'll use, for instance, like when a soybean plant gets white mold, or when corn ends up getting northern corn leaf blight, the plant gets infected, the tissue starts to die, the disease starts to proliferate and grow within the plant. The plant then, it's kind of the 5-alarm fire. The plant all of a sudden is like, oh, I've got to do something about this, but there's a lag period in there, and I'll show that in a minute. So that's kind of a systematic, because there has to be an infection before I'll respond, is kind of the big thing there. The herbivore-induced resistance, kind of the same thing, but that's where we're actually losing tissue, whether it be to insects, deer, anything like that. it'll trigger a signal that, hey, I've been damaged here. I need to allocate resources to, heal up that wound site or do whatever I need to do. Maybe we need to kill that leaf off and move those nutrients somewhere else, or kill that branch off. That's what a plant will do, and when it's being fed on. And then the ISR, the induced systematic resistance, and this is really what we're going to talk about. So that's where you get colonization of a plant through the bacteria. In this case, would be the PPFMs, that essentially act like a vaccine or act like a signal that turns on the plant's defense mechanism so it's prepared. Essentially letting somebody know. It's like if in football, if anybody was watching football yesterday, it'd be essentially like if the Rams would have had the Seahawks playbook before the game, they may have had a little bit better success. So that's essentially what we're doing, is we're giving the plant a heads up to get ready for an infection. So when an infection occurs, or we have that problem, that the plant can act faster. So there's a really good visual right here. So this is kind of how that works. So you can see on the bottom there, the blue line, the no priming. So this is exactly what would happen in a normal plant's life cycle. Plant's growing along, lying straight across. All of a sudden, you can see the little picture there, the rootworm, the larva. So what happens is we start getting that feeding. The insects are going to have time to feed before the plant then can react to that feeding. And so plants will actually produce jasmonic acid on their own. That acid I talked about that blocks the CO2 receptors, they will start producing that on their own. That is their natural mechanism. But by the time that the rootworm larvae, especially in heavy pressure, have started feeding, that lag time is too long to get the rootworm to stop, essentially. So you can see that period from the rootworm to that peak is a lot bigger. If you jump up to the top, so we prime that plant with a PPFM. In this case, would be the Rhipel. So there's a little kind of priming. The plant kind of ramps up its defense mechanism. It kind of acts, like I said, like a vaccine, ramps up the defense mechanism. There's no insect damage present, no rootworm present. Plant goes through its normal thing. But the difference is, as soon as that plant starts being fed on, it's a quicker and larger defense. So it kind of reacts and kind of shuts everything down before we start having issues. So I really like this slide. Kind of explains the process really well. Okay, so here's kind of a rootworm life cycle. This is a pretty generic slide, so forgive me for, I know that not everybody's planting, has V2 corn late April. But just kind of for all intents and purposes, this is kind of a slide I really like. So everybody always asks, well, can we just use this, instead of a rootworm trait, instead of like a Vorseed or a SmartStax Pro or a Duracade? In this case, we recommend, it's a suppression label only. In high rootworm pressure environments, we are not recommending this as a standalone with above ground or no protection at all. Going into some of those, call it like 10, 15-year corn-on-corn environments where we've been using traits. But in moderate to low pressures, cases with extended diapause, or like in cases where we're using the trait and maybe we want a little additional protection, this is a very, very good option. And the reason we recommend using it in conjunction is with a trait, every rootworm larva has to take a bite before they die. They still have to feed no matter what you do. In this case, we don't have to have that feeding to essentially get the suppression. So this stops and essentially helps the plant and the trait work better, because it stops a rootworm from even getting to those roots. And I've got some pictures later on here that kind of explain, what that damage, because a lot of guys think, well, if I got 5% root feeding, I got most of my root system. There's not that many problems there. So all those feeding points when those rootworm larvae are chewing on that root system are entries for fusariums, pythiums, lots of root-borne diseases, which can lead, like fusarium, can lead to crown rot later in the season. Not only that, but you lead to side-to-side stability in the plant. There's a lot of other things that go into it. So if you look at this here, about between V4 to V6, usually about V5, is when rootworm traits begin to express proteins. So that's generally when they start, essentially that gene in the plant turns on to make the proteins that kill the actual larva. And I realize that for a lot of guys, the V2 to V4 might be that late May, early June, or it could be, depending on who's on this call, it could be late April, just depends on where we're talking. the biggest thing I want to stress is how many years have we been, accumulated GDUs early on, because the larvae and rootworm larvae are all driven by GDUs for hatching. So we could be accumulating GDUs, but say it's too wet to plant, or we're accumulating a bunch of GDUs and then we get too cold, so we wait on planting, and then we get a bunch more GDUs, get some rain, and our planting gets delayed. Well, if we've got larvae hatching, say mid to end of May, and say we're putting corn in that Memorial Day weekend, one of those late planting years, we're putting corn that's at V1, 2, 3, 4 while there's larvae there, and they're, even though it's a traded hybrid, and it doesn't matter the brand, the company, the trait, even though it's in the ground, that trait's not being expressed, so we're still getting early feeding. And the last thing you want to have, if you guys have ever dealt with white grub or any of that, or even wireworm, where we're dealing with feeding on the roots and or the embryo before the plant can essentially get established and get up and out of its the most stressful period that it's going to go through, it really, really hampers yield. So that's where the biggest thing, and guys ask, well, why would I use this in conjunction with traits, is we're getting that season-long protection with RhizoStack Rhipel. The other thing that a lot of people don't think about, and it does, once again, doesn't matter the rootworm trait in the market today, they're all the same, is we have 5% refuge in those bags, whether it's Legend seeds or the Nationals, you name your seed brand. Because of EP regulation, we're 5% is refuge in a bag. Well, that 5% does not have rootworm protection, and that's what that's designed to do. So if we can essentially help those 5% gain a little bit more yield, there's added protection that way that a lot of people don't think about. So, but that's kind of the thing, and that RhizoStack Rhipel, granted, we don't have a lot of flushes after tassel, below ground, but it's in that plant working throughout the entire season. The one thing that this will not do, so just like on traits, is this does not stop silk clipping. So we still recommend that if you're in high rootworm beetle environments where we've got, because it'll essentially stop a lot from hatching, but you're still going to have some larvae that just happen because of the grace of God. They hatch and their face is right on a root, and they start to feed. They go through their normal processes. That if it's untreated corn, they emerge. We're still going to have some beetles that emerge. So best management practices would be to, if we're spraying a fungicide pass, or if we're just trying to manage rootworm, would be going in and bug bombing that at that tassel timing to stop the silk clipping, because that's a one thing that the RhizoStack Rhipel will not have the power to do, is stop that silk clipping. Okay, so here's kind of in the soil. So this is kind of I like this visual. So this was a study that was done by the supplier, and this is in, I believe it was University of Missouri that did this. So it was in a lab. So this is kind of just a visual of what it was. So what they had, so on the right was the untreated check. So they essentially had two test tubes. They put a pile of larvae and soil in between the two, and they released them, kind of like if you've ever seen they do like wiener dog races or minnow races at the bar. It's kind of the same concept, but they put them in there to see which way they would go, if they would go to untreated check or if they would go to the RhizoStack Rhipel. So when they did this, 70% of the larvae took a right and went to the untreated roots. 26% of the larvae stayed in the center and did not move. The other 4% of the larvae decided to go to the Rhipel. Okay, so this isn't just a 2-plant 1 study. This was replicated multiple times, multiple different entries on this data. So then when they took and put the RhizoStack Rhipel in both tubes, and then essentially in that connection point, put the larvae, 80% of the larvae remained undecided and stayed in the center. So that's essentially showing that, there's some that we're still going to have some that for whatever reason, maybe the way the concentration of jasmonic acid is moving through the profile, or they hit an earthworm channel and they're easier to move, they can move easier without hitting that band of jasmonic acid. They're still going to find that root system. So it's, like I said, it's not 100% control, but having 80%, if we can stop 80% of the feeding, even on traded corn, if we can stop 80% of that feeding from ever happening, that's a huge win. So yeah, there's the data there, it says, so conducted University of Missouri in 2023. So it's a couple-year-old study, but this is kind of what, to give you guys confidence when I show you these root pictures, if you kind of visually think of that 70 to 80% reduction and kind of everything we just talked about, when I get to the pictures and the images, it's going to kind of all make sense here. So Okay, so the RhizoStack Rhipel will also enhance the root throughout the season, kind of like I talked about before, the RhizoStack portion of that. So, and it's mainly doing it at those nodal roots, the nodes 1, 2, and 3. So the first nodal roots that come out. So as a corn plant starts making its root system, yeah, obviously node 1 is the first one that comes out, then it's node 2, then node 3, and so on and so forth, and stacks it up. So node 6 is the last one to emerge. That's essentially your brace roots. Node 5 and below is your root crown. So what they're seeing is an increase in the amount of root tips at node 1 to 3. Total root length, especially the smaller, fine, fibrous root hairs that are picking up nutrients, those kind of things. Often those are fed on. Those are kind of called like the silent problem. When we have rootworm feeding, everybody always looks at, as an agronomist, we dig up a plant, we put it in a bucket of water, wash around, try to get the larvae to float to the top. Then we try to hose them off or pressure wash them off, get your genes all full of mud and dirt and everything. And then you start looking at what's called the node injury scale. So, and what that scale is it shows how much of a node has been fed off. So it's really looking at node 5, 4, and 3. And what you're looking for is if a whole node's been fed off, it gets a score of a 1. If 2 nodes are gone and fed off, it's a 2, and so on and so forth. But what we really lose is that those fine fibrous root hairs that are getting clipped off all the time are very, very hard to see with the naked eye, especially when we're digging it out of the ground, trying to wash it off. A lot of those fine fibrous root hairs are pulled off through that process. So it's what we're losing that we don't necessarily see. So like we're putting, for instance, we're putting, infertile fertilizers, those kind of things, any other biology or nutritionals that we're putting in that furrow, that's where node 1 to 3 is going, is right in that seed trench, right around that seed zone to take up that nutrients. If we're getting that fed off, it defeats a lot of the purpose of what we're putting down, or even stuff that we're putting in a 2x2x2 placement. So then if you look there as we go up, so node 4, so higher up the plant, so increase root tips by 10% and total root length by 9%. And then as we went up to node 5, increase the tips and then the length. So essentially as we go up the nodal system, the less and less long they get. We're still increasing length, but it's incrementally less. And then when we get to the top, when you get to the brace roots, we're not really seeing any enhancement at that node. Those are really more anchoring and stability roots. They do take up a bunch of nutrients and water, but their main function is for standability. Node 5 is the most important one, and I'll show some pictures on why that is here in a second. So I was talking about that damage, like what we don't really ever think about or see. So you can see on the left there, so the tunneling damage. So not only do rootworms clip off, if there's enough pressure, they will feed right through an entire root and essentially clip it off like if you took a scissors. But they'll also do a lot of tunneling. And what that tunneling, it kind of is just like if you took you're scooping ice cream out of a pail and you take that, go across the top of it and you leave that trench. That's essentially what they're doing to that root system. So when we have that on the control, that infection never heals. So that essentially is like a wound that kind of just stays rotting and squishy all season long. It might start to dry up and kind of scab over, but it never truly heals up. And that is an entry point for, especially like the last couple of years, we've been dealing with a lot of crown rot over here to the east in Wisconsin, Minnesota, Michigan, anthracnose. That's an entry point for lots of diseases. And that's kind of a secondary benefit to this product that we don't really talk about. But now I'll go over to the right. You can see where we have, so on that main stem there, you can see where we've got that. It's kind of hard to see. I don't know if you guys can see my cursor, but right in this region here, if you look, you see that kind of brown discoloration where you can see that tunneling effect. Look at the root system, the node above that. Look at the regeneration that we're getting. So this is the same hybrid, same everything. Treated RhizoStack Rhipel to control. And this is early on. This is, I believe, V4, V5 corn. So, early on feeding, but look at that stimulation of the meristematic tissue in that roots to gain root system. So it's not necessarily, what do I say? It's not necessarily scabbing that over completely, but having a healthier root system above that versus having that rot off and damp back and have nothing there for a root system. That's where the big benefit is coming from. So here's a visual. So this is just a root dig looking at, so this is later on in the season. But RhizoStack Rhipel on the right, and then just a regular check or gourd standard practice on the left.
The big thing to note here is look at the not only the root depth, so we're getting a little bit deeper roots. The root structure of that hybrid is all the same. It didn't change anything there, change, lateral branching, anything like that. We're just getting a lot longer root system that goes deeper into the profile. The biggest thing is the bottom picture is the big take home here. Look at the how far out we're getting those roots. Kind of a more, call it, even root system where we're not dealing with, like anything where we're losing roots on one side or planing out. That root system for center of gravity and for keeping a plant upright, we've got a lot bigger footprint essentially for that plant to essentially stand up and then also take up nutrients, those kind of things too. Because if we have a root system that's, say, heavy one side or the other, we fed off one side. Well, if we're putting, say, a 2x2 application of something down on that one side, or there's a fertilizer band on that one side, like say in a strip till situation, if we lose that root system on that side, we're not getting access to any of those nutrients or anything that's in that profile off to that side. So having that more uniform root system side to side, left to right, however you want to look at it, is the big thing there. So okay, so these are some of my pictures that I've taken just throughout the couple of years here that we've been working with this product. So this is down kind of in it's western Wisconsin, very, very heavy intensive corn on corn environment. If you look at the difference in feeding here, so on so this is on a Power Core hybrid. So on the left was an untreated check, and then on the right is the RhizoStack Rhipel. If you look, and it's kind of hard to see in these pictures, but you can see the kind of brown discoloration on a lot of those nodal roots, especially set 4 and set 5. There was quite a bit of rootworm feeding on, especially this one. You can really see those are all fed off right through there on set 5, and some damage. But look at the tunneling. You see the brown discoloration in those roots on the left. All the tunneling we're getting down those roots and kind of that scarring effect down every single nodal root as it's going down. Look at the picture on the right. Now, don't get me wrong. There's still a couple. You can pick out a couple small areas, but see how much more vibrant and white that root system is, the plant health overall with the root system. We're getting a lot less of that nodal feeding. So we're not losing any nodes to rootworm. We're not losing, say set 5 or set 4. We still, you're going to have a little feeding, so we still have a little tunneling, but the overall just lack of feeding on that root system. And then you can really see, like I said, that like in the middle of that root canopy on the right, you see all those fine fibrous root hairs and the mass that's right in there. Now, if you go over to the left, no, don't get me wrong, there's still some there, but there is drastically more of those small, fine nodal root hairs on the right there. So, okay, so everybody says, okay, Jake, that's cool. That's an untraded hybrid. Of course, you're stacking the deck in your favor. What about, what if you use it on a rootworm trade? So this is on a smart stack. So a little bit different maturity, same exact area. So if you look at the difference there, so the untreated check is on the left. The treated is on the right. There you can see on this one, if you look close to the bottom of both of these plants on the untreated check, you see a lot of that brown discoloration. Especially this one, you can really see a lot of tunneling. But we're not losing those nodes, right? The trait is working the way it should. And these roots aren't clipped off. That was a heavy piece of trash that was in that one. So those roots are still healthy. Now going over here to the right, so this is the trait with the RhizoStack Rhipel on it, so essentially double layering that protection. Virtually, there's a couple tiny little spots where we have a little bit of tunneling, a little bit of feeding, but very, very clean, not losing any nodes, anything like that. So very, very good control. So everybody always asks, why would I use this with the rootworm trait? This is kind of the picture. The other thing is we still get the yield benefit out of the TerraSym 450. Which is now called RhizoStack. You're still getting the yield component. So say rootworm never show up, we never see any kind of insect pressure in that field for whatever reason that year, and you're like, well, I just toss that money down the drain. There's still a yield enhancement component to this product. So with that TerraSym 450 being in there, so. Okay, so just something that's new, kind of shifting gears a little bit here off of rootworm. So RhizoStack Rhipel now has an extended label for 2026, and I really think that this is going to be huge for a lot of acres. So we have corn rootworm, which we talked about. We also picked up wireworm. So no-till guys, cover cropping rye, after sod, stuff coming out of CRP for a long time. or just fields with lots of waterways, field edges, that kind of thing. Wireworm is kind of probably the most forgotten about insect, especially where I live here in Wisconsin. We're planting into a lot of cold soils, a lot of no-till in some areas. And that's wireworm is one thing that really, you start losing 2,000-3,000 plants the acre, that can be really detrimental to yield. So, and like I said, there's no trait out there that controls wireworm, but with that Rhipel, like I said earlier, Rhipel is from day one. When we put that seed in the ground, when that seed germinates, these PPFMs are getting in there and going to work doing what they should do, and that's how we're able to control that wireworm damage. I also picked up weevils, thrips, stink bug, fall armyworm. I know that's a really big issue in areas that are heavy single trait Roundup, conventional corn. I know in my home state of Wisconsin, they were a big problem in very isolated areas. It wasn't widespread, but the guys that had them, it was a disaster. So we did pick up an armyworm on that label, and then as you can see to the left, we also have there's soybeans, cotton, and rice are also on here. So soybean looper and then root knot nematode on all crops. So that's something we're kind of excited about. I think it opens up the market to our dealers and our customers a little bit more, that we're not just getting a corn rootworm product here. This is more than rootworms. If anybody's got questions, feel free to call, text, email me anytime. Otherwise, thanks everybody for getting on, and we'll see you next time.